In this video, we're gonna type the HDL code for a 2-to-1 mux using one else statement, and we'll also test it using EDA Playground website. We'll first start by adjusting the settings of the website by changing the language first to VHDL, and then we'll type Testbench as the top level entity, which is going to be the Testbench code file name. But remember, Testbench is one word without the extension. And then we'll choose the first tools and simulator, the first one on the list. And then we'll tick the box where it says open EP-Wave after run. This will ensure that the timing diagram window will open once we click run if there is no errors in our code. Next, before we start typing any code, we're going to erase our design.bhd code, and we'll click on new to create a new script file. We'll call it mux_21.bhd, mux_21.bhd. Now we'll click create file. We'll first add our library declaration files, and we can also put our name as a comment, for example, so it will be here. And then we're going to start by saying entity. The name of the entity is the name of the file without bhd, so it will be entity mux_21 is and mux_21 semicolon. For the entity part of a 2-to-1 mux, we have to declare two inputs that we want to choose from and one select bit. Because we have two inputs only, we can name them as A and B, or 0 and 1, so for that we'll need one bit. Port A, B, and S, our select bit. These are all inputs, so we'll say in, and these are all single bits each, so STD logic. Now semicolon, because we'll list our output, we only have one output named Y. We'll say Y is an output and it has one bit, so standard logic. Now this is the complete entity part. Finally, we'll declare the architecture. We're going to say architecture behave, that's going to be behavioral modeling code, of mux_21 is begin end. Between begin and end behave, we're going to use the when else statement to mention that we want y to be equal to a when s is 0, and we want y to be equal to b when s is 1. So the way it works is by saying y is assigned a value equals to a when s is equal to single quote 0, close the quote, semicolon. Before the semicolon, we're going to say else, and then, because the statement is not complete yet, so the else part, in the else part we'll say b. That means if s is 0, y is equal to a, else or otherwise y is going to be equal to b when s is equal to 1, and then we'll put the semicolon. That's the end of the statement. Now we'll go to our test bench code for the 2-to-1 mux and copy it, and we'll erase the current test bench code and paste our 2-to-1 mux test bench code. Notice here the name must say mux_21. Now we'll click run to check the timing diagram. Notice how, let's put the cursor first. Here, A is 0, B is 0, S is 0. When S is 0, we're going to select A. That means Y is equal to A. Let's examine a different value, for example here. At this particular moment, A is high or 1. A has a high edge or 1. B has a low edge or 0. S is also low or 0. And our code says when S is low or when S is 0, Y is equal to A. So Y has to have a high edge, just like A, which is true. So if you check all the cases in this timing diagram, there should be 8 possible cases. You should see that the results in this timing diagram match exactly the results in the truth table of the 2 to 1 mux that we know.